Hi everyone, I'm Stormtracker 16's Jeremy Lewan. Thank you so much for joining us in this week's episode of Stormtracker 16 Cloud to Ground. We're here at Steamtown National Historic Site in front of the famed Big Boy 4014 and its tour across America. And in many ways, the weather acts like a train. Thunder echoes through the sky like a massive train rumbling down the tracks. Where there is lightning, there is thunder. Now let's kick things off with Joe Snedeker's Lightning Round. Time to turn up the heat, Joe.
Alrighty, folks, welcome to the Lightning Round. Nikki, do you know about this? People send in questions and we answer them every week?
Yeah, I heard about it.
Yeah, so if you got a question, it's weather@WNEP.com. It could even be an angry question. Is this even a question?
I don't think it's a question.
I brought in a professional broadcaster to read this thing like only a skilled professional can.
Boy.
Hit it.
Game 6 of the Stanley Cup Finals. Carolina could win the cup. NHL fans wait for it all year. You take over the second period, put the game in a box in the corner and cover it partially with your box, and take over audio. It's absolute nonsense. It's one thing to put the weather warnings up, but to take over the entire game, complete BS.
Whoa! So what happens? I didn't know of this specific instance, but we shrink everything down and it's still there, but then the weather warnings take up the whole screen. That ticks a lot of people off. And I want you to know, it's not Kurt Aaron, it's not Jeremy, it's not Ally, it's not me. We don't do that. It's management, and even above management, do you know it's the federal government? They mandate local television stations to keep viewers alert to major warnings that happen weather-wise. So let me just offer you this. Do you know the difference between a weather watch and a weather warning?
I think warning's the worst one.
Yeah, so a watch just means conditions are ripe for something to happen. Could be a tornado in the next hour or two, a thunderstorm, downpours, hail. But if it's a warning, guess what that means?
You gotta be on TV.
It's happening.
Yeah.
So in that case, I think there was a tornado warning, which means a tornado was happening in parts of the area. Tornadoes take lives and destroy. Yeah. So what we have to do is warn people. For a lot of folks, that's the only way to get it. So I'm sorry if it ruined your big NHL game, but there were lives at stake in a warning. Okay?
Okay.
Is it okay then?
I guess. Game 6 though?
Game 6. We got to keep people alive. Thank you. All right, next question, Nikki, comes in from Sam Frieder from Wilkes-Barre. He said, could you explain how thermometers work? He said, old school liquid ones like with the red dye and the mercury, they seem outdated anymore. How about the big dial ones and digital ones? What do you think about this? So if you would hold this for a second, your typical thermometer, you know how that works, right?
Yeah.
You got the red liquid, which is alcohol or the mercury. It heats up, the molecules expand and they go up the tube. And that's how we read temperature, right? But what about something like this?
I've never thought about it.
Well, look what's on the back.
Not a lot.
Dun, 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 dun. You see that little coil?
Yeah.
That's just like the red alcohol or the mercury that's in an old school thermometer. When temperatures get warmer, guess what that metal does? It expands.
Oh.
Just like your hair expands and contracts in humidity, or a lot of things expand and contract in different temperatures. So when a metal expands, what does it do? It's longer.
Yeah.
But if you coil it up, longer means it uncoils. And that makes this little dial go up.
I never knew that.
So it's the uncoiling of the metal when it heats up that makes this thing read a higher temperature. And when it gets cold, the metal contracts and that causes the coil to shrink and that causes it to go the other way.
Oh.
Isn't that pretty cool? It's called a bimetallic thermometer. They're not as accurate as the real ones, but it's okay, right?
Yeah, close enough.
They look cute.
They do.
Don't they? And the final type of digital thermometer, that simply uses an electrical current to register how warm or cool the environment is, because currents travel at a greater ease through warmer temperatures. So that's pretty much it. Pretty cool, huh?
I never knew.
It's bimetallic, baby!
Ooh.
Keep the questions coming. Weather@WNEP.com. And this has been the Lightning Round.
Thanks, Joe. We always want to be sure that we do our part to keep our area informed and safe when things take a turn. And speaking of spinning, in many ways the weather acts like a train. Storms can roll across our region like a big train, slow but impossible to stop. And Kurt Aaron answers another student's question about the powerful hurricane.
And welcome back to the WNEP Backyard. Hi, I'm Chief Meteorologist Kurt Aaron. Gotta say, the backyard garden's looking really good. Hopefully we have a great harvest again this year. All right, it's time for science class, and we had this question asked about hurricanes.
How and why do they choose the names for hurricanes?
That's a great question, and we're gonna get help answering that question from Mitchell from the National Weather Service. So to do this, we need to go back to the severe weather set. Let's go. And welcome back to science class right here in the WNEP severe weather set. Now, Mitchell with the National Weather Service I was telling you about, he can't be here, so instead, Mitchell's going to join us on a Zoom call.
Well, my name is Mitchell Gaines, lead meteorologist at the National Weather Service office in Binghamton, and today I'm going to go over how hurricanes get their names. So way back before the 1950s, hurricanes were just mentioned as a year or just a day, like the Labor Day hurricane or the Galveston hurricane. There wasn't really any naming. It wasn't until the 1950s until hurricanes started getting female names, and then in the 1970s, male names were added as well. And we go through 6 different lists of hurricane names. A famous hurricane will get retired if it causes an extensive amount of damage, really strong, like a Category 4 to a Category 5. We go through each list once every 6 years. The names are actually set by an organization called the World Meteorological Organization, and they come up with names from both English, Spanish, and even other regions of the country and the world to which the names are generated. So we start this year. Of course, we already had our A storm. We'll go A through Z. And then if needed, we've had a couple of times in the last 15, 20 years where we've gone to even had to go to the Greek alphabet. There have been so many hurricane names.
So I find it very interesting that back in the day, you said before the 1950s, many times it would be named for an event that's going on. Or can you imagine trying to read off latitude and longitude for each storm as you're out in the sailing or something like that? It's much easier to give it a name. And wasn't it in the 50s, they named them, the sailors named them after girlfriends or wives or things like that when they started doing that?
Yes, yeah, that's part of it. Why they got to be more female names at first, and yeah, back then they didn't have all the satellite data that we do today. Well, it was a lot harder to obviously find the center of circulation and be able to track where it's going. So we actually still do have hand hurricane tracking charts for the use. Like we give them out to tour groups and other agencies where you can hand track the hurricanes.
That's nice.
But a lot of it is just through satellite. We look at the different heights of the cloud tops and the temperature of the cloud tops. All the way down to the surface. And then we have our hurricane hunter aircrafts as well, which go into the storms once they get closer to land.
Every 6 years, the names are recycled. Are new names added every year? And if so, how do they pick those names?
Well, they tend to pick simple and easy to pronounce names, although you have the cultural element as well. So not everything straight up in English. And if we have a retired system like Hurricane Mitch was retired, Hurricane Katrina was retired, then a new name will be added to that list. And it'll be up to the World Meteorological Organization to determine what name goes on the list. But that's why every 6 years, like you'll have a lot of Hurricane Arthurs, for example, or Tropical Storm Arthurs. Those come up once every 6 years. Typically, your A storm is not the strongest storm of the year. So right. If the name hasn't been retired, it'll come up once every 6 years, depending on how active the hurricane season is.
And now, Mitchell, let's talk a little bit about the dynamics of tracking these tropical systems and hurricanes. You were talking about a hurricane hunter. Those are pretty impressive aircraft.
Oh, yes. We have Hurricane Hunter aircraft that'll go out multiple times. and it's really neat inside the aircraft. There's not a lot of extra room, but you can see in the aircraft the area where they have to launch the weather balloons into the storms that collect a lot of data. They go in and out, so they'll go from the eye wall to the outer rain bands, and they're trying to establish what the pressures are and what the wind speeds are, because that determines how strong a hurricane is. And so they'll be moving in and out of the storm, and then eventually they have to come back and refuel and then head out again. So all of that data is fed into our computer models, which we use to project what the weather could potentially be over the upcoming 7 days.
Weather's fascinating to me, and I really appreciate you taking the time out. Well, Mitchell, this has been wonderful, very informative. I know our viewers, especially the fifth grader that asked the question, will be able to take a lot from this. And we thank you so much for your time, and thank you for what you guys do at the National Weather Service.
All right, Kurt. Well, thank you very much for having us on, and we hope to be back on again. It was a pleasure talking with you all today.
Well, thank you, Mitchell. We appreciate it very much. Let's take a look at next week's question.
I want to know, how do ocean currents affect climates?
And that's a great question, and we will have answers to that next week on Science Class. Until then, have a great night.
Thanks, Kurt. It'll be interesting to see how far down the list we get this season. Anthony Bordenero is up next with a look at how light bending in the sky gives off vibrant colors. Cloud to Ground will return in a moment. Welcome back to Cloud to Ground. I'm Jeremy-Lenticular. Since engines like these release exhaust steam out of their smokestacks in the form of water vapor, if the sun is bright and positioned in the right spot, you could get a mini rainbow to appear. Did you know why some rainbow arches are different than others? Sometimes there's only a sliver of it in the sunshine. Anthony Bordenero is here with his whiteboard weather to discuss.
It is not all sunshine and rainbows here in whiteboard weather, but this week it actually is. Let's get into it. This week we are talking all about rainbows and circumhorizontal arcs. Now that probably seems like a mouthful, but we've seen a few here across Northeast and Central Pennsylvania. Here are a couple of viewer photos, including some photos of me. It is interesting to see when running what you can capture. That's why I always like being outside and running. It's always a nice time. But some people call it a fire rainbow, but they're called circumhorizontal arcs. I'm going to show you how rainbows form and how they form and why they're a little bit different. So we all know what rainbows are. They are the bow that forms and you have a bunch of suspended water droplets here. They reflect rays back to your human eye, and it creates a rainbow on the opposite side of where you're at. Now let's talk about circumhorizontal arcs. They form up in the sky at a higher sun angle. So let's flip the board. And let's get into the nitty-gritty of both of them. So here is your suspended water droplet. These water droplets are in the order of millimeters to maybe centimeters thick, but start from red and then it goes all the way to violet. That's the visible light that we see. The thing you got to understand about red light is it has long wavelengths. But we'll skip a few steps. As you skip to green, let's just say, the wavelengths get a little shorter. Then as you skip to violet wavelengths, that's the really short high energy wavelengths. So what happens is you have a beam of light, it makes contact with the water droplet, and now it splits into all the different bands of light from red to violet. So it starts off, we'll just simplify and say red and violet. What happens is this longer wavelength doesn't get reflected as much as the violet does. So it continues on its path relatively. It bounces off this side, keeps its angle, and then departs on this side, like this. With violet, it bends more. So it goes from here to here, from here to here, and it bends like this. So you can see the difference there. The violet and then the red. Key thing to understand about circumhorizontal arcs is that instead of water droplets, they are ice crystals, flat ice crystals. And they're so rare because the ice crystals need to be flat. If it's even tilted a little bit, it ruins this whole process. So you have a light ray. It comes in from the side and it bends the light. Purple ends up coming out like this, or violet, depending on how you want to say. And red ends up coming out more like this because the purple is bent more. So you're like, Anthony, okay, so the purple is up. So why is purple not the top of the rainbow? Why is purple towards the bottom? Well, you have to picture where the water droplet is. So let's draw it a little bit bigger. Let's say it's here. So the violet gets reflected, but it misses your eye. But the red gets reflected and it hits your eye. That's why you see the red in the higher water droplets. Now the bottom, let's do the bottom. The violet gets reflected right into your eye, and the red gets reflected down, so it misses you. So you can see the red when it's higher. You can see the violet when it's lower. You can see the red when it's higher. You can see the violet when it's lower. The concept for rainbows is similar for circumhorizontal arcs. There are a couple of differences between the two. Because you're talking about the reflection of the water droplets, you need 42 degrees or lower sun angle for the rainbow. But for circumhorizontal arcs, you actually need a higher than a 58 degree sun angle. So with 42 or lower sun angle, that happens any time of the year. So you can expect it anytime in northeast and central Pennsylvania. But of course, they're less likely during the winter because we don't see that much rain during the winter. We see that in snow. But for the circumhorizontal arcs, we can only see it from April through September. And it only happens midday when the sun angle is the highest. And of course, for rainbows, you need rain. For circumhorizontal arcs, you need a clear day. So it's pretty much the opposite. You need a clear day where you can see those upper level ice crystals that are suspended in the clouds very high up in the atmosphere. So they're a little bit same, a little bit different, all good views.
Thanks, Anthony. Rainbows come after a good rain event, and Ally-Gallo has one rain event that left much of the Wyoming Valley underwater. That's next on Cloud to Ground. Welcome back to Cloud to Ground. I'm Jeremy-Lenticular. Do you know someone who was involved in the Agnes flood of 1972 just over 50 years ago? Perhaps you and your family experienced it. Let's check in with Ally-Gallo, who explains that rain that sometimes falls on your head isn't as consequential as the rain that falls in New York State. Ally?
Hi, I'm Stormtracker 16 meteorologist Ally-Gallo. Last week, the first named storm of this hurricane season formed and made landfall in Texas as Tropical Storm Arthur. But if you live in the Wyoming Valley, this week you're probably thinking about another A-named storm, the first of the hurricane season in 1972. Of course, Hurricane Agnes. It's been more than 5 decades since Agnes changed our area forever. So this week, I take a look back at that devastation 54 years ago this week.
The storm developed in mid-June and intensified to a named hurricane on June 18, 1972. Hurricane Agnes made landfall near Panama City, Florida on June 19th and rapidly weakened. Agnes then re-strengthened into a tropical storm on June 21st, and by the next day, on the 22nd, the storm changed course and made a northwest curve, again making landfall near New York City as a strong tropical storm. Then it settled over Pennsylvania and upstate New York on the 23rd.
What really hit you was when you came back and actually saw your home. That was devastating.
Agnes is remembered as the wettest tropical cyclone on record for Pennsylvania. Parts of the area received up to 19 inches of rain. The storm caused flooding at a scale never seen before. More than 100,000 people in the Wyoming Valley were told to leave their homes. On the morning of the 23rd, just after 10 a.m., the siren wailed. The levees meant to protect Wilkes-Barre and the many communities around it began to fail, and water from the Susquehanna River came rushing in.
Get out now. Get out now. There's still time, but this is the warning that the river is starting to come over the dike.
Work on the dikes has ceased. The water is expected to break through.
Agnes put fear into people, real fear, and it put real sorrow into people and heartache.
In June of 1972, Mike Stevens was in his 20s working in the radio industry. Newswatch 16 sat down with him a few years ago for the 50th anniversary of Agnes.
We started doing public service things like evacuation here, and you can get food over here, and they have a helicopter landing pad over there. So we were able to do that as a public service for the community. And that was the beginning of the Agnes flood story.
Just the beginning of what Mike would later realize was one of the biggest stories of his career. Jay Christopher was tracking the storm here at WNEP that week in 1972. Back in 2022, he told us he vividly remembered what he was thinking and feeling at the time.
I went to work, it was on a Wednesday, and I went to work. I didn't know if I was going to get home that evening because things were already getting very tenuous. But we didn't know exactly how fast it was going to come up. Nobody really knew. But the only thing that was known then was that the dike was not going to hold.
He, of course, was right. And the levee raising in the Wilkes-Barre area was the biggest project to come after the destruction from Agnes. Jim Brozina was just a junior in high school in 1972, but in '79, his career came full circle when he began working for Luzerne County as an assistant engineer.
One of my first tasks when I went to work for the county was to go to a meeting at Wilkes College about the raising of the levees. The federal government said right after 1972 we're going to increase flood protection. They were still working on it, and basically I worked on the levee project my entire career.
Brozina worked on the $200 million project from 1996 to 2005. 1 year later, he became the executive director of the Luzerne County Flood Protection Authority. He said he felt confident in the levee and its ability to withstand whatever Mother Nature threw at it. Then in 2011, Tropical Storm Lee hit. River levels crested well above flood stage, flooding homes and businesses throughout the area. But it could have been a lot worse.
If that levee raising project had never occurred, I mean, the valley would have been destroyed a second time in 2011, and in the same generation. And I think this valley would look much, much different than it does today.
In 2022, a documentary about the preparation, destruction, and recovery surrounding Agnes premiered at the FM Kirby Center.
The Kirby Center is actually, which was the Paramount Theater at the time, is actually in the film. And it would have been the last place on Earth you would have wanted to be on June 23rd, 1972, because it was under about 12 feet of water.
A theater once filled with water was filled with people wanting to mark the somber 50th anniversary. The film's director wasn't alive to see the flooding, but felt compelled to share the impactful stories with a new generation.
From someone who didn't experience it, seeing what I saw when I was making the film was just breathtaking. You couldn't imagine that something so horrific happened in this area.
Next week, I take a look back at the weather here in northeastern and central Pennsylvania on the 4th of July. The hottest, the chilliest, and the rainiest. Thanks for joining me this week. I'm Allie Gallo.
Thanks, Allie. Now that the train has left the station, the tracks are quiet, almost like the calm after a storm. It's times like Agnes when we see our communities coming together to support each other. It sure was a long road to recovery. Finally, today on Cloud to Ground, I'll have some of your photos that show a particular kind of cloud formation. We'll talk it out when we come back. Welcome back to Cloud to Ground. I'm Jeremy-Lenticular. Cold fronts arrive sometimes like a long train, pulling into the station, bringing in gusty winds, shaking trees, and rattling windows. Clouds in your pictures depict such volatility. Here they come in This Week in Weather. So let's get started with this incredible shot from Mike, just to the north of Bloomsburg in Light Street. Take a look at this. This is a striking capture of a lenticular cloud, glowing bright in the sunshine, almost sculpted against that bright blue sky. Its smooth, layered shape gives that classic flying saucer appearance, while the dark gray underbelly adds a little drama beneath the sky above. It's the kind of cloud that makes you stop and stare. These clouds form when strong winds flow over mountains or hills, creating waves in the atmosphere. Then moist air rises in those waves, cools and condenses into these smooth lens-shaped clouds. Even though the wind may be roaring through the atmosphere there, the cloud itself can appear perfectly still, almost suspended in place, like a flying saucer. And while they may look soft and peaceful from a distance, lenticular clouds are often a sign of powerful air movement overhead, and that's something that pilots know very well. I'll always end this segment with a photo that made me smile, and I want you to take a look at this beautiful shot from Beth. Love this picture in Montoursville, right along Bennett's Run, a tributary that flows into the mighty west branch of the Susquehanna. It captures a quiet early morning along a rushing Bennett's Run, water surging past the rocks while a fisherman waits patiently with a rod in hand. And then there's the dog, standing proudly at attention on the boulder, eyes locked on the water, clearly invested in the success of this fishing trip. You can almost imagine him waiting for the moment that the fish breaks the surface. Behind them also, you can see that beautiful rising sun glowing warm orange through a soft veil of fog, giving the whole scene that peaceful, just after sunrise calm. And that's what I love about this photo. I love how it quietly connects back to our lenticular cloud. It might be peaceful, just like the lenticular cloud sitting there, sometimes levitating over a hill. But this image shows that the rushing water beneath is shaping the land below, just like the rushing air over the mountains shaped the sky into something beautiful in the prior picture. Two very different scenes connected by motion in nature. One overhead in the atmosphere, and this one right here on the riverbank. And sometimes all it takes is a good dog, a fishing rod, and a sunrise to remind us how beautiful those moments can be. Well, that does it for this week's episode of Cloud to Ground. Thank you so much for joining us. We're honored to be part of such an amazing railroad legacy here in Scranton. Ending off our segment with the Big Boy 4014 with another Jeremy from the National Park Service. Jeremy, how much longer do we have to be able to witness something like this here in Scranton?
We've got about another week through Tuesday, June 30th for everybody to come down to Steamtown National Historic Site to see Big Boy 4014 and Big Boy 4012.
Well, thank you so much for having us. Thank you for your information.
Thanks, Jeremy.
And we'll see you right here next week for next week's episode of Cloud to Ground. I'm Jeremy-Lenticular.